Welcome back to the channel, crypto enthusiasts. Today, we're diving deep into one of the most exciting developments in the Ethereum ecosystem, Layer 2 solutions. If you've been involved in crypto for a while, you know that Ethereum is one of the most widely used blockchain networks, hosting thousands of decentralized applications. However, as more users joined, the network started experiencing congestion, leading to high gas fees and slow transaction times. To address these issues, developers have introduced what's known as Layer 2 solutions. In this video, we're going to break down what Layer 2 is, why it matters, and how it's revolutionizing the Ethereum experience for everyone. Let's jump in. To understand Layer 2 solutions, we first need to grasp the basic structure of the Ethereum network, also known as Layer 1. Layer 1 is the main blockchain where transactions and smart contract executions take place. As Ethereum grew in popularity, the number of transactions increased, causing congestion on the network. With a limited number of transactions that could be processed per second, users began facing extremely high fees and slower transaction confirmations during peak times. This is where Layer 2 solutions come in, offering a way to offload some of the network's activity onto secondary layers, which then communicate with the main chain. Layer 2 solutions aim to improve Ethereum's scalability by processing transactions off-chain and only submitting the results to the main chain. This approach reduces the workload on Layer 1 and minimizes congestion, leading to lower fees and faster transaction speeds. There are different types of Layer 2 solutions, each with its own method for scaling Ethereum. Among the most popular are rollups, state channels, and plasma. Each of these solutions has a unique way of handling off-chain transactions, but they all share the goal of making the Ethereum network more efficient and user-friendly. Rollups are one of the most widely used Layer 2 scaling techniques. They work by bundling multiple transactions into a single batch or rollup and then submitting this batch to the Ethereum mainnet. This means that rather than processing each individual transaction on Layer 1, the network only has to verify the rollup itself. There are two main types of rollups: optimistic rollups and ZK rollups. Optimistic rollups assume that the bundled transactions are valid by default and only run fraud proofs when a transaction is disputed. Scrollups, on the other hand, use zero-knowledge proofs to instantly verify the validity of transactions, offering even faster confirmation times. Optimistic rollups have gained popularity due to their compatibility with the Ethereum Virtual Machine (EVM), which allows developers to deploy existing Ethereum-based dApps onto Layer 2 with minimal changes. One example of an optimistic rollup solution is Optimism, which has been widely adopted for scaling decentralized applications. By moving most of the computation off-chain, Optimism can significantly reduce gas fees, making it more affordable for users to interact with dApps. Another example is Arbitrum, which also leverages optimistic rollups to provide a more scalable environment for Ethereum applications. These platforms have quickly become favorites among developers looking to scale their projects without sacrificing decentralization. Scrollups are another type of rollup that uses zero-knowledge proofs to validate transactions. The ZK stands for zero knowledge, which is a cryptographic technique that allows one party to prove to another that a statement is true without revealing any additional information. Scrollups offer a higher level of security because they mathematically ensure that all transactions in a batch are valid. One of the most well-known ZK rollup solutions is Sync, which has gained traction for its fast confirmation times and lower fees. Because ZK rollups are more complex to implement than optimistic rollups, they are still in the early stages of adoption. But many believe they hold the future of Ethereum scaling due to their potential to handle more transactions with greater efficiency. State channels are another form of layer-to-solution that allows participants to conduct multiple off-chain transactions while only settling the final state on the Ethereum blockchain. Think of it like opening a tab at a bar. Instead of paying for each drink individually, you pay for all of them at once when you close the tab. State channels are ideal for scenarios where two parties need to exchange value frequently and don't want to pay gas fees for each transaction. However, they are not as widely used as rollups because they are less general purpose and better suited for specific use cases like gaming or microtransactions. Plasma is yet another scaling solution that creates a framework for building child chains that run alongside the main Ethereum blockchain. These child chains can process their own transactions and submit periodic summaries back to the main chain, reducing congestion. However, Plasma has faced challenges with complex exit mechanisms and limitations in its usability, which have caused it to be overshadowed by more efficient methods like rollups. Nonetheless, it still plays a role in the overall layer-to-scaling landscape. The adoption of layer-to-solutions has the potential to revolutionize the Ethereum network by making it more accessible for everyday users. Lower fees and faster transaction times mean that dApps can offer better user experiences without worrying about prohibitive costs. This opens the door for Ethereum to be used in more everyday scenarios, such as microtransactions, gaming, and other applications where low fees are crucial. Additionally, as Ethereum transitions to a proof-of-stake consensus mechanism with Ethereum 2.0, layer-to-solutions will continue to play a critical role in ensuring that the network remains scalable and sustainable in the long run. One of the most significant benefits of layer-to-solutions is their ability to make decentralized finance DeFi more accessible. The high gas fees on Layer 1 have been a barrier to entry for many people who want to participate in DeFi protocols. With Layer 2, users can engage in activities like trading, lending, and staking without worrying about exorbitant transaction costs. This democratizes access to DeFi, enabling more people to take advantage of these innovative financial services. Additionally, some layer-to-solutions, such as ZK rollups, offer enhanced privacy features, which could attract more users to DeFi by providing better protection for sensitive financial data. While layer-to-solutions have made significant progress, there are still challenges to overcome. One of the main issues is user experience, as moving funds between Layer 1 and Layer 2 can be complex and time-consuming. Developers are working on solutions to simplify the process, such as layer-to bridges and more user-friendly wallets. There's also the matter of security, Although Layer 2 solutions offer significant improvements, they still rely on the underlying security of the Ethereum network. Users must be aware of the trade-offs when using Layer 2, especially when it comes to projects that haven't been thoroughly audited. Looking ahead, the role of Layer 2 solutions will continue to grow as Ethereum scales. Ethereum 2.0 and Layer 2 are not mutually exclusive, but rather complementary. The transition to Ethereum 2.0 will improve the base layer's scalability, while Layer 2 solutions will further enhance the network's capacity by offloading activity from the main chain. As new scaling techniques are developed and existing ones are refined, Ethereum will be able to accommodate a broader range of applications and a larger user base without compromising on decentralization or security. If you enjoyed this in-depth look at Layer 2 solutions, make sure to like the video and subscribe for more crypto content. Let us know in the comments which Layer 2 projects you're most excited about, and if you think they're the key to Ethereum's future scalability. Thanks for tuning in, and see you in the next video!